produced by Avocado Predictions.
Holy moly, guacamole! Hello viewers, today's video is about... Wait, I forgot again. What's it about, Sai?
Kinda, you forgot to introduce us! Hello viewers, I'm Sai.
And I'm Kinda.
Today's video is about the immune system! Music please? Thank you.
Now, where were we? Oh yes, the immune system. The immune system is a complex system that helps the body fight infection, but fighting the infection isn't always easy.
You know, kinda, it's like a war. Not easy for one side to defeat the other. Think of the body as a whole force trying to fight foreign substances. The immune system has many defense mechanisms, ranging from the outer non-specific defenses to the more complex specific defense. All parts of the immune system are highly important in order for the body to be able to save itself if a foreign antigen presents itself into the body.
In a real war, one side would consist of governmental support, soldiers fighting, volunteers providing resources, and spies gathering information. In the war, the body, or specifically the immune system, consists of many parts that help to prevent foreign substances from infecting a person. The enemy would be the antigens, which are foreign substances that enter the body.
So let's start with the guards who surround the army, which is non-specific defense. They're a lot like a shield that protects the body from foreign substances. They protect the body, always being the first line of defense that bacteria and antigens face. Non-specific defenses include the skin, mucous membranes, stomach acids, resistant microbes, nose hairs, and the inflammatory response.
Skin consists of many layers that prevent foreign antigens from entering. The skin's outer dead cells prevent bacteria or other harmful substances from entering the body. Not only does the skin guard off the foreign substances, but it also consists of special glands called sebaceous glands that give off oil. This oil is used to kill the microbes which are trying to enter through the skin.
Mucus, along with skin, is also a non-specific defense, and it uses a similar method to skin to fight against foreign invaders. The mucus lines the respiratory tract in order to trap the pathogen before it reaches the lungs. The lungs are one of the most important organs in the body, because without them, we wouldn't be able to breathe. If a pathogen were to get to the lungs, serious breathing problems could occur, so never complain about how disgusting mucus is, because it's actually fighting against infection.
Don't complain about nose hairs either, because they do almost the same thing as mucus and skin. Nose hairs block out environmental pathogens like germs, fungi, and spores from entering your body. When you breathe in, all the pathogens naturally found in the air follow through the nasal cavity. The hairs are like a sifter, catching them before any harm can be done. After these first lines of defense, there is a second line of non-specific defenses, which includes inflammation and fever. These forms of defense also prevent diseases from affecting the body. When a pathogen stimulates an increased blood flow to an infected area, an inflammatory response begins. White blood cells begin to crowd after the blood vessels expand. They surround and invade the bacteria until it is destroyed. From a visible and emotional view, the site of the inflammation would appear red, swollen, and painful. The body can also try to protect itself by raising its temperature. In other words, it produces a fever. Fevers burn the pathogens and antigens up, killing them off, while speeding the process of the immune response.
Now, as you probably noticed, non-specific defense is a protection or guards for the first contact the antigen makes with the body. But when the antigen gets past the non-specific defense, that's where the specific defense comes into play. The specific defense is a part of the immune system that consists of different mechanisms that act against antigens once they've entered the body. This is where it gets complicated. Non-specific defense protects against any pathogen, whereas specific defense attacks certain pathogens. And, that's why it's called specific and non-specific. Come on, viewers. You know this. But, you know this.
B cells are cells that produce antibodies. They're kind of like a factory. B cells are a type of white blood cell that alert macrophages of infected cells. When a B cell comes into contact with a foreign antigen, it begins to raise an alarm. From there, the B cells quickly begin to clone themselves. Some of the clones become memory cells. These cells record the genetic code for antibodies in the event that they must be used again. Other clones become plasma cells, which are also known as effector cells. These are the cells that actually do the combat fighting, destroying the antigens.
Continuing with the soldiers who are fighting the war, antibodies are the basis of antigen identification. When an antigen enters the body, B lymphocytes produce antibodies. The antibodies stay inside the body and are there so that they can recognize and attach to the antigen if it ever appears again. This way, the person will not get the disease over and over again. One example is the flu. Every year, a flu vaccine is available to add in very weak or dead antigens for the cells to be able to use as identification to kill. However, because this virus changes each year, the vaccines must be administered each year. One's immunity is also a factor of this. The more someone is exposed to a foreign invader, the more immune they are to it, and the more the antibody recognizes it, so it actually protects the body even more. Antibodies also neutralize toxins and help activate complements, which are specific proteins that are part of the immune system and help to kill foreign substances.
The T-cell's main job is to destroy the antigen after it has been attached to the antibody. Some T-cells also send cytokines, which are chemical messages, to the immune system, and some help B-cells with the production of antibodies. T-cells also signal other cells, like phagocytes, to function correctly.
Phagocytes are white blood cells that ingest the foreign substances to prevent infection. It binds with the bacteria and ingests it. Sometimes after ingestion, they kill the bacteria with oxidants. Then, during antigen presentation, the phagocyte moves the ingested bacteria to its surface and take it to the other parts of the body, like lymphocytes. This helps maintain a stronger immunity, although some antigens are able to survive the phagocyte. Phagocytes also remove dead cells, and by doing so, they help maintain tissues.
So the immune system is a very crucial part of the body that prevents you from being sick 24/7. But, wait a second, I thought, aren't there some cases in which the immune system actually attacks healthy cells? And, well, it just seems ironic considering that we've been proving that the immune system is a hero all this time. Have we just been proving a pointless point the whole time?
Well, kinda. It's sort of true. When the immune system attacks healthy cells of one's body by accident, then the person has autoimmune disease. Their body cannot differentiate healthy cells and the cells of foreign invaders. Autoimmune disease often shows symptoms such as inflammation, fever, skin disease, joint pain, and tiredness, and the list goes on. There have been about, let's say, 80 to 100 different types of identified autoimmune diseases, including rheumatoid arthritis, an inflammatory disorder affecting the joints. Scientists do not know what specifically causes autoimmune disease, but it is often caused through genetic history, smoking, weight, and some types of medications. Autoimmune disease is also most common in women, especially under certain races. In fact, more people in the US have autoimmune disease than many other diseases such as heart disease. So we can't completely say that the immune system is the savior of our body because at times it can turn up against our bodies. Yes, it does use different incredible types of defense to fight off many pathogens and complicated methods. Without the immune system, we couldn't eat just any food freely because there wouldn't be anything to fight off food pathogens. Think about it. No ice cream, chocolate, or pizza. Well, then again, I suppose Veitho could live happily without the chocolate, but imagine such a tasteless world. But there's the consideration of our immune system being against us. For the most part, however, let's just say the immune system overall fights off most pathogens.
Well, Sai, it's been a pleasure talking to you about the immune system. Now I feel like I understand it so much better. Well, thanks for watching! It took a lot of work to get this all together. First of all, Sai did an amazing job of writing parts of the script and researching a lot of information.
We also like to thank Kaina for editing the script and researching a lot about the immune system.
We'd also love to thank Veitho, who's been doing a lot of the behind-the-scenes work with editing and filming. I see a wasp. Outside of that.
Blah 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 shit.
Beak cell.
Beak cells.
This video is about hemoglobin.